Okay, welcome back. We are for notes number 4. So hopefully yesterday you went through notes number 3 on slope and watched that video and then worked through the homework number 3 on delta math. I am sitting here on, what day is it? Wednesday afternoon doing these notes, and I just checked delta math and I only had one person who had totally completed the homework on delta math. If you're having any troubles with that, please let me know. But you want to make sure that you're doing these in order. Otherwise, you'll kind of lose track of what you're trying to do. So make sure you've done homework 3 before you jump into this stuff. Okay, so now that we've talked about slope, we're going to learn how to graph lines using slope-intercept form. And this is the most popular way to graph linear functions. It's probably the one that you've learned before. It's the one that people remember and we focus on a lot. So once we know slope and how that works with linear functions, we can use slope-intercept form. And slope-intercept form looks like this. It's y equals m times x plus b, right? And we've got some parts in there. We want to make sure we understand what they mean. M, just like we saw yesterday in notes number 3, M is for slope. And B, we haven't talked about before, but the B is going to stand for the y-intercept, right? So if you've got an equation in slope-intercept form, you can immediately pick out your y-intercept and you can pick out your slope. And that means we have 2 things that will allow us to graph this. Okay, so let's kind of do one together just to see how we use it to graph. So let's say we've got y equals 1/2 times x plus 3, right? So if it looks like that, then our slope is the number that's right next to the x, or being multiplied by the x. So our slope here would be 1/2. And then our y-intercept is the number by itself. So our y-intercept, or what we call b, is 3. Okay, so then to plot or graph our line, we're going to start with our y-intercept. We want to do that first, right? So I plot my y-intercept at +3, just like we did intercepts before. So I'm going to go up to 1, 2, 3, and plot that point. And then, just like we did yesterday, we can use our slope to find more points. So I would go up 1 and to the right 2, and I plot another point. And I can do that again. I can go up 1 and to the right 2. Now, when you're doing slope, you can also do the opposite. I could go down 1 and left 2. That was in yesterday's notes too, right? If both numbers are positive, we can also write that as both numbers are negative, right? The second thing we're doing is using our slope. Okay, so then we've got some points plotted here on our graph. Once you've got those plotted, you can use straight edge or do your best to draw your line. So then we've got our line plotted, right? So then we can see our y-intercept is there, right? We'll make it the same color. And then our slope is going up 1 and to the right 2, right? So rise over run. And we've got our line graphed. Okay, that's all great if we've got it in slope-intercept form to start with. Sometimes equations will look a little bit different, and there's certain things people get confused on. So I wanted to go through a few equations that look a little bit different so we can make sure we know what to do when things look a little bit different. Okay, first, this one hopefully we'll do okay with, but if I've got the equation y equals -x plus 2. A lot of times people want to say that if I ask, like, what's the slope? I'll hear, oh, it's -x. X is not part of your slope, right? The x is just the variable that is next to the slope. Slope is the number that's in front of the x. So technically, if you want to write this out with your slope showing, this would be y equals, and the number in front of that x is -1x plus 2. So then that means that our slope is -1. And then again, if it's helpful to you to always write your slope as a fraction, if it's a whole number, you can always put that over 1. So that'd be -1 over 1, right? Or like we talked about yesterday, you could make that 1 over -1. Either way is okay, right? But our slope is -1. And then our y-intercept, the +2 part, so b equals 2, right? Okay, so there's one. All right, the next one similar. We've got y equals x plus 3 and that whole thing over 2. So it still says y equals, which is what we want for slope-intercept form, but that over 2 is underneath all of the x plus 3. So to make this look more like it's in slope-intercept form, we want to split that up and put x over 2 and 3 over 2, right? So, and also remember there's a 1 in front of this x, right? So I'm going to rewrite this as y equals, and then I would put 1x over 2, or remember you can write that as 1/2 x, and then plus the 3 also has to be divided by 2, so 3/2. And then it looks like it's in that y equals mx plus b, so our slope would be 1/2, and our y-intercept would be 3/2. And yes, it's okay for a y-intercept to be a fraction. I won't do that to you a lot because I know it's a little bit harder to graph that way. Usually we'll have whole numbers, but your y-intercept can be a fraction. That happens. Okay, good. The next one, this one looks a little bit different. Y equals 4, right? So we've got the y equals part, but there's no mx. There's just a b, right? There's no x in this equation. So on this one, we could add in an x, but it would have to be plus a 0x, so we don't change the value of the equation. So this would say y equals, and then I could put in a 0x, and then we'd have our minus 4. Now it looks like y equals mx plus b, right? So then our slope is 0, and our y-intercept is -4. Right? So if there's no x there, that just means that your slope is 0. Okay, good. Next one, I run out of colors here. Our y equals -7x. Okay, so this time, again, we've got our y equals. We have our x term, but this time there's no plus number, like plus a b, right? This time we're missing b. So just like when we didn't have the 0x or the slope with the x, we added in a 0. We can do the same thing if we're missing the y-intercept. So I'm going to keep my y equals, I'm going to keep my -7x, and then I'm just going to do plus 0. So then it looks like that y equals mx plus b. So in this case, then our slope is -7, and then our y-intercept would be 0 because we added that on. Okay. All right, and then our last one here, what color we have left? How about an orange? 2x minus 4y equals 16. Okay, on this one, the only problem is it's not y equals, right? So anytime you're going to graph using slope-intercept form, you have to put it in that y equals form. This is why we practiced this a couple homeworks ago when we first started this unit. So this one, I'm going to take the 2x minus 4y equals 16, and I'm going to get y by itself. So I'm going to subtract 2x to the other side. So that'll give us -4y equals. Now on the other side, I can't do 16 minus 2x. Those are not like terms. So I don't do 16 minus 2 and get 14. You can't do that because those aren't like terms. So we talked about before, we just write what it says, right? We would write 16 minus 2x. But our slope-intercept form is mx plus b. So if I want to put it in slope-intercept form, I want to put the x term first. So I'm going to write the -2x first, and then I have a positive 16. So I just changed the order just to make sure it's in that slope-intercept form. Then to get y by itself, I got to divide everything by -4, and you got to make sure you do every single term. So then those -4s are gone. We get y equals a -2 divided by a -4. That's going to make a positive number, and 2 over 4 would reduce to 1/2. We still have our x. And then 16, positive 16 divided by -4, that would make -4. Okay, so then our slope would be the number with the x, which is 1/2, and our y-intercept would be the -4. Okay, so just a few kind of equations there that look a little bit different to start with, but they're still almost in slope-intercept form. You just may have to kind of change a few things up to get what you need. Okay, so now let's try actually graphing a couple of these. And we kind of talked through this a little bit in the first step, or in the first part of the notes, but to start, anytime you want to graph a linear equation, first thing you want to do is get it in slope-intercept form. Meaning, basically, if you have to, you're going to want to solve for y, right? Get y by itself. Once you've got it in slope-intercept form, write down your slope, or your m, and your b, your y-intercept, right? Write those down so you know what they are. After you've got everything set up and ready to graph, you're going to start by plotting the y-intercept. So plot the y-intercept, which is b, right? Then, once we've got our y-intercept, we're going to draw, and this is kind of a silly word, I guess you could say, but some people will call them slope triangles, so that we can find more points on the line. And finally, we're going to draw a line to connect the points. Okay, so going through all those steps, we'll kind of do each one here and try a few examples. So the first one, y equals negative 3x plus 2. So our first step is get it into slope-intercept form. That looks like y equals mx plus b to me, right? So we've got our parts. Then once we've got that, we're going to write down our m and write down b, right? So our m is the number that's right in front of the x, so negative 3. And again, if you want to, you can always put that over 1 to make it a fraction. A lot of people like to do that. And then our y-intercept, or our b, is that positive 2. So 2, right? Okay, our next step, we're going to plot the y-intercept. Always start with that first point, that y-intercept. Remember, y-intercept means that it's on the y-axis, and the y-axis is the one that goes up and down. It's the vertical axis. Okay, so I'll go to positive 2. There's my y-intercept. Then we're going to draw slope triangles to find more points, right? The slope triangles just mean this. The slope, remember, is rise over run, right? So the way I have it written up here, it's negative 3 over 1. So negative 3 means I'm going to go down 3. So 1, 2, 3, and then over positive 1. So that means I'm going to go to the right 1, and then I'm going to plot another point, right? And eventually, you don't have to draw in every little dotted line like this, but that's what I meant by slope triangles, right? And then once you kind of understand it, you're just going down 3 and to the right 1, and then plotting a point. Okay, now we can also do the opposite with the slope. So if I went down 3 and right 1, like we said before, I can also write this slope as positive 3 over negative 1, right? So I could also go up 3 and to the left 1. And that still works for our line, right? Once I've got my entire coordinate plane filled up with as many points as I can, then I'm ready to draw in the line. You can use a straight edge. Like I said, your ID works pretty well, or just do your best to draw it as straight as you can, okay? That's how we graph a line in slope-intercept form. Ta-da! Okay, next one, same idea, right? We want to graph using slope-intercept form. Now this time, it's not solved for y. We need to do that first. So we're going to take our 4x minus y equals 3. We want to get y by itself, right? So I'm going to subtract the 4x over to this side. And now watch your signs here. There's still a negative y left over, right? That negative is important. And then I can't do the 3 minus 4 because that's a 4x, so they're not like terms. But again, we're going to put the x term first. That way it looks like y equals mx plus b. So I'm going to put negative 4x first, and then plus 3, because it's a negative 4x and a positive 3. Okay, then I don't want negative y, I want positive y. So I'm going to do the opposite of everything, or basically we're dividing everything by negative 1, if you want to write it that way, right? So then we get positive y equals positive 4x minus 3, right? So there's our slope-intercept form. Now we can take out our slope, which is positive 4. And again, if you want to put it over 1, you can. And then our y-intercept would be negative 3, right? So there's those two pieces. Okay, so then we plot y-intercept first. Our y-intercept is negative 3, So I'm going to go down 3 and plot a point. There's our y-intercept. And then count out your slope. It's positive 4, right? So that means we're going to go up 4 and to the right 1. And we put another point. And then fill up your coordinate plane. So up 4, right 1. That's as far as I can go. And then remember, you can do the opposite of it. So if it's 4 over 1, that's the same as doing negative 4 over negative 1, because a negative divided by a negative is a positive, right? So I could also go down 4 and to the left 1, and I can put a point there. Okay, that's as much as I can fill up. So then I'm ready to draw my line. And there we go. And on both of these, based on what we talked about yesterday, if you know it's a negative sloping line, like in the first one, right? We had a negative slope. If you have a negative slope, remember it should be decreasing as we go left to right. So as I move my way across the graph, this should be going down, which it is, right? So it's a decreasing slope because it's negative. The other one, I've got a positive slope, right? That's a positive 4. So as I go this way, it should be going up, which it is. So that's one little quick check you can do to make sure you've got your slope plotted correctly. Okay, so there's our positive and negative sloping lines. Let's look at the other two we talked about yesterday. So this one is y equals 3. Now, if you remember from yesterday, this means, or I'm sorry, not from yesterday, but what from we talked about in the notes up above, there's no x term here, right? There's no number next to x to make a slope. We want it to look like y equals mx plus b. Well, that means I could put a 0x in. So we could call this y equals 0x plus 3, right? So then our slope is 0 and our y-intercept is 3. Okay, so then we plot our y-intercept, which is 1, 2, 3, and then our slope is 0. So remember, that means if it's 0 over, I can put it 0 over anything. Come on, pen, there we go. But easiest is just put it over 1, right? So that means I rise 0, but I am going to run over 1, right? Or I could run over that way. But if I'm not rising at all, then my points are just going to go this way, right? Or they're going to go this way. So that's going to make a horizontal line. Okay. So if it's just a y equals, like this guy, right? That means that y always equals 3. Right? No matter what x value I pick, y is always going to be 3. So if I've got a horizontal line, no matter what point I pick on that line, like say I pick this point right here, that point has an x value. It's at 1, 2, 3, 4, 5, 6, right? No, 5. So that x value is 5, but the y value is 3. If I pick a point over here, that x value is -2, the y value is 3. Every point on that line has a y value of 3. Okay? So if you see a y equals like that, that's a horizontal line. Okay? All right. Then we've got x equals. Now again, this one is not in y equals mx plus b. In this one, we run into a little bit of a problem. We can't put it into y equals mx plus b because there's no y. So we can't write it as y equals mx plus b because there is no y, right? At least in the horizontal one, we could plug in that 0x. But you can also think about this one as x always equals -1, right? That's what this part says here. It basically means that x will always equal -1. So no matter what y value I pick, x has to always be -1. So I'm going to go to where x is -1, and that's on the x-axis, it's -1, right? Now, if you remember, let's talk about this way. If I keep going and I want another x value of -1, where I could pick any y value I want. So I could go up or down. I can go up here to this y value as long as x is still -1. I could go down here as long as x is still -1. So this one's going to make a vertical line. And if you remember from yesterday's or notes number 3, a vertical line has a slope that's undefined, right? Because I can go up and down, so I can have a slope where my top number is 1, but the bottom number has to be 0. There's no run. I'm not going to the right or the left, and that 1 over 0 is undefined. So a vertical line has an equation that's just x equals. Okay, so horizontal is always just y equals, vertical is x equals. Now, people get confused on these because you guys are used to the fact that the x-axis, right, that's this guy, goes from left to right. But when I do a line that's just x equals, like this guy, it's actually a vertical line. And then same thing with the y equals. The y-axis goes up and down, but if I have an equation that's y equals, that's a horizontal line. So make sure you know the difference between the x-axis and the y-axis, and then versus like an x equals is a vertical line and a y equals is a horizontal line. Okay, this takes a minute to get used to, but once you've got your horizontal and vertical lines down, the best thing is just to memorize it. Know that a horizontal line has a slope of 0 and it has a y equals equation. A vertical line has a slope that's undefined and it has an x equals equation. Okay, that's the best thing you need to do is just have that memorized. Okay, so there's our slope-intercept form with lines. We will have another homework today that's on delta math, where you're just plotting lines and graphing lines, using your y-intercept and your slope. And then we've got another one where you're changing from a form and putting it in y equals form, so kind of like we did in this example. Okay, use your notes if you get stuck on the homework, or send me a message if you've got a problem, and we'll go from there. Best of luck, and I will hopefully see you guys tomorrow. If you haven't listened to this yet, then I saw you today.